we've spent quite some time looking over ways to describe rational functions. But something a lot of people tend to forget is that graphs are ginormous, because graphs tell us the inputs and outputs for every real number. These graphs will keep going to a billion, to a trillion, to a Google. They just keep going. These things right here are asymptotes. Any holes that happen here, when our function is just 1 over x, like this right here is, all those things don't really matter anymore. So how can we describe our function when our graphs become so massive and our inputs become so massive? The process of doing this, describing functions when their inputs get extraordinarily large and these things become very small, like the scope, is called end behavior. End behavior asks, when our inputs get very large, how does our function behave? It goes as this. We say, as x approaches infinity, as our x values get bigger and bigger and bigger. Of course, they're approaching infinity. They're not approaching a million and then they stop. They keep going. As x approaches infinity, our function, I'm just gonna, 1 over x. As x approaches infinity, 1 over x, what happens to the graph? It gets smaller and smaller and smaller and smaller and smaller. Not what value does x become, but as in the same vein here, what value does f of x approach? We say as x approaches infinity, we can say f of x approaches, at what point is this approaching? It approaches 0. And now for the other side here, as x gets infinitely far away from 0 on the negative side, so as x approaches negative infinity, where does our function go? Just like on this side, it also gets smaller and smaller and smaller. So, as x approaches negative infinity, f of x also approaches 0. Now, that tells me that when the range of this whole graph, the window of it, we're in the billions, doesn't matter what it is, it's going to approach 0. And no matter how far away it gets to the other side, it's going to approach 0. And now, what of our horizontal asymptote? Well, we can see that as x approaches 0, it's going to get very, 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 very large. And as well from this side, as x approaches 0, it's going to get very, very large negatively. But here, x is approaching 0 from 2 different points. How can we describe it's approaching from the left and then from the right? Well, we do this denoting it with a plus and a minus. So if we say that as x approaches 0, as it comes closer to this side, closer to our asymptote, 0 from the right, which we denote as a plus, our f of x, our function, our outputs, are going to get very, very big. They're going to get ginormous. It doesn't just stop at a certain point. It's going to go on our inputs can be 0.00001. There can be a billion zeros and then a 1 at the end. It's going to approach infinity. So as x approaches 0 from the right, the plus tells us it's from the right, our function approaches infinity. And as x approaches 0 from the left, we denote that with a minus. F of x approaches, you can see instead of going up, it just goes down to the negatives, negative billion, negative trillion. It approaches negative infinity. This is the process of end behavior, describing what our graph is going to look like when our window gets extraordinarily big. Now, this is not true for every function, right? If our asymptote was different, if this was 1 over x plus 1, our asymptote would instead be over here. And now our functions would then be approaching that 1. We would then say instead that as x approaches 1 from the right, f of x approaches infinity. And if our horizontal asymptote was different, if we were moving up 1, then it would get smaller, 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 but it would still approach 1. So as x approaches infinity, right, our inputs are going to keep going, f of x is going to approach that horizontal asymptote. And that is end behavior. And now with that, I believe that rounds out how to describe rational functions. Had lots of fun drawing graphs. Drawing lines like these, as straight as these, a lot harder than you'd think. But yeah, end behavior, describing functions. Very fun and very cool. Have a good day.